Schema design in ClickHouse directly affects how efficiently data is stored and how much data needs to be read, making queries faster. Let's take a look at the different decisions you need to make when designing schemas in ClickHouse so you can turn terabytes of data into milliseconds. Okay, mastering ClickHouse schema design. So let's see some of the principles you need to learn. First of all, the smaller the data types, the less storage, fewer bytes scanned. This is good for reads. Sorting keys are the most important thing in ClickHouse because sequential access is generally 5 to 10 times faster than random access. And if you combine that with cache and compression, you can get to 40 times faster queries. For instance, if you are filtering by a column that it's not in the sorting key in your queries, ClickHouse is going to perform a full table scan. So you must take this into account. And there are some interesting specialized types, for instance, LowCardinality, that can reduce repeat string storage and speed up some operations. Storage and compression, again, sorted data compress much better. There are compact numeric types, for instance, unsigned integers that reduce disk usage and I/O. And it's very important to choose the right codecs in ClickHouse. For instance, delta encoding can dramatically shrink date times. Just remember, the less data on disk means cheaper storage and faster queries. There is a trade-off when designing schemas in ClickHouse. You either have to choose between flexibility or stability. Just remember that schemas in columnar databases are really hard to change for different reasons. First thing is tables are very big, and because of the design decisions of the database, they are sometimes immutable. So you need to decide on a good upfront design. Usually you want to normalize your tables, but take into account there are developer tools, some interesting developer tools that simplify the schema evolution process. So you might have the best of two worlds. You might have stable schemas, but with the flexibility of being able to evolve them as you wish. It's not that you have to optimize schemas for performance, but of course you have to take into account the semantics of your data and take into account that picking the wrong types can corrupt your results. For instance, you have to make decisions between decimal or float data types. Usually decimal are better for amount calculations. Nullable versus defaults, there is some semantical difference between them. And of course, the precision of your date times can also make more difficult to analyze your data depending on your date granularity. The wrong schema design can have hidden costs, especially operational costs. Remember, storage is not always cheap. Even cloud storage can be quite expensive. Of course, for slower queries, you need more cluster nodes to compensate. This is more CPU, more money. And migrations, when you have to fully rewrite huge tables, of course, can be expensive as well. Okay, let's start with some examples. I'm going to start the Tinybird Docker container, which contains ClickHouse server. And we can open a client on it. And this is how you create a table in ClickHouse. Create table, events, the columns, data types, the engine, which is mandatory. We will talk about it in the next video, and the sorting key, okay? Once you have these, you can insert into events some values, for instance, 1, 2, and 3. And we have our first table, okay? So there are 4 options, basically, when you want to design your schema. Well, there are probably more, but sometimes you already know the schema of the table you want to create. This is completely fine. You know your data. For instance, you have an events table with an event time, a user ID, session ID, blah, blah, blah. And you exactly know the data types. You know you want to use the merge tree and sort by event time because you're going to do like time series. This is totally fine. And once you have it, you can just start ingesting your data. For instance, I'm gonna ingest, let me make this smaller, 100 million rows, okay? Other option is you don't know the schema yet, but you have some sample of data. There is a describe command in ClickHouse. For instance, we're gonna use describe table from a Parquet file we have in S3. And this is gonna give you, let me make it smaller. This is gonna give you the different columns and the different types. It's not very good because it's assuming every column can be nullable. It's a perfect schema decision, but maybe it's not what you want. Remember the schema semantics of your data. There are other APIs for this. For instance, I'm going to log into Tinybird and I'm going to choose, for instance, this workspace, a local workspace, and I'm going to do a request to the analyze API with my workspace token and the very same Parquet file. And you're going to have a very similar result, but in this case, it's not detecting nullables, okay, in the data types. And it's also adding the JSON paths. We will see this in a later chapter, okay? Another option you may consider is using AI-assisted schema design. To be honest, this is very convenient to me. Let's try the very same example, create a data source based on this schema, and I send the URL. It's gonna do basically the same thing. It just detected we want to create a data source. It's gonna grab the URL and it's gonna call the very same API. And you have here the full schema ready to be deployed to your workspace, okay? You might not use sample data, but you can say, okay, create a data source for an uptime monitor analyzer, and based on the semantics of what you want to build, it's going to create like a sample data source. You can then refine and iterate on it, okay? This is an example. It decides to have a timestamp, a service name, a URL, the status, response time. It pretty much makes sense. So this is another way to start designing your schemas. There is another way which consists on using predefined schemas. For instance, if you go to tinybird.co templates, there is a template for OpenTelemetry. So let's take a look at how it looks like, because OpenTelemetry is a very well-known technology to ingest logs, traces, and metrics. And we already have, for instance, schemas that are already designed for this type of data. For instance, for logs, we have timestamp, timestamp time, trace, span, trace flags, blah, 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 with the proper codecs. For instance, for timestamps is using a delta codec, which is very convenient. The right sorting keys, you usually want to first filter by service name, then a timestamp, etc. Same with traces, for instance. In this case, it's using proper LowCardinality data types. For categorical columns, again, compression as needed, and arrays and maps when flexibility is needed, okay? With this in mind, you can deploy the complete set of schemas with a single command, which is very convenient. So you can use TB Cloud Deploy and the URL of the GitHub repository, and it's gonna clone all the schemas and they are gonna be deployed to your Tinybird workspace or your local Tinybird container, okay? These are 5 simple rules for data type selection in ClickHouse. First, use strict types. Usually instructor types means slowness in some kind, so if you can avoid them, do it. Prefer minimal precision types, so whenever you choose a date, a string, and a number, choose the right precision for your data, avoid nullables if possible because they add some overhead. Low cardinality for categorical data, they have a huge improvement on compression. And then if you plan to use other types like enums, maps, arrays, evaluate carefully. Arrays are usually fine, but others might need carefully evaluation. ClickHouse implements a bunch of codecs to compress data. Usually configure them at database level, but there are specialized codecs you want to include in your column definition when you are designing your schemas. When talking about compression, you have to take into account three concepts, which is compression means less data transfer, so you can process more data in less time, despite of the CPU overhead you might have. There are specialized codecs, for instance, delta encoding, which is good for increasing numbers of daytimes, in which you calculate a delta, which is the difference between consecutive numbers, and this is going to give you better compression. And finally, any compression algorithm has a CPU overhead, but that's overweighted by the reduction on I/O. So whenever you can, use compression in ClickHouse. Okay, let's see an example. We're going to create another table with the same schema of the previous ones, but we're going to use delta compression plus CSTD and another compression algorithm. So we're going to see the difference between them. Okay, so we create the table and we're going to populate it with the same data, the same 100 million rows. If we look at the system columns, we can see there is a huge difference, for instance, between event time compressed with delta codec and with regular compression. We used low cardinality for the path column compared to the regular string column. And you can also compare the rest of the columns, for instance, revenue, status, or the user ID. So it's very important that you carefully evaluate your compression mechanisms so you can store less data and make your queries faster in ClickHouse. Data locality is a concept extremely important in ClickHouse, and it depends on how you design your sorting key. It's better if we take a look at some examples. We have this events row table with 100 million rows, ordered by event time, and we have a separate table which is events opt, order by event time and user ID. Let's see what happens when we filter by event time and user ID in events row. It's gonna do a full scan and the query is taking 300 milliseconds, but in the table that is order by event time and user ID, we're gonna see that it's gonna scan way less rows and it's gonna be one order of magnitude faster. But what happens if on that very same table we filter by a column that it's not in the sorting key? What we're gonna see is we're still doing a full scan and queries are slower. So this is the importance of the sorting key ClickHouse. Take this into account when choosing your numeric types in your ClickHouse schemas. First, the smallest integer the best, but take into account numeric overflows. There is a decimal data type which is good for amount calculation, and you can use float for the rest, ratios, approximations, etc. And unsigned types are usually compressed, usually better. Use them for IDs or any other column that you are sure it's not negative. Let's take a look at some examples. So we're gonna start by creating a table with 4 numeric types, an unsigned int, and 4 more with different precisions. And what happens if we insert 10 million rows, 10 million consecutive numeric numbers on these columns? What's gonna happen is that the column we set as an integer of 8 bytes is not gonna support our semantic numeric system, and it's gonna overflow. So this is something you have to take into account. On the other hand, there is one interesting thing about numeric precision, which is, let me make this smaller. So as you can see, integrate is the one that best compresses, but in this case we cannot use it because we are overflowing, but int16 is better than numeric data types with higher precision. So take that into account when designing your ClickHouse schemas. Let's try now to make some comparison between float and decimal data types. So first we're going to create a money float table with a price with a float data type and another one with decimal. Okay. Now let's ingest 1 million rows, and let's do the same in the other table, and let's see what happens when we sum the price in the money flow table. It's gonna give us this precision, but if we do it in the decimal one, we're gonna see that numbers don't match. Okay, in this case you're gonna trust the decimal data type, so make use of it when you have to do money calculations on ClickHouse. 3 simple tips when designing your schema for strings in ClickHouse. First thing, use fixed string for codes, for instance, country codes. Low cardinality, very important. It's gonna give you huge savings on storage, but also faster group bys and faster queries in general. And of course, avoid low cardinality for high cardinality columns. Okay, let's see how low cardinality can improve storage. For our events row table, we have 100 million rows. This is the schema in which we have a country column, which is a string, and we're gonna create a separate table in which we're gonna set the country as a low cardinality fixed string of 2 characters, or 2 bytes in this case. Let's copy data from our events row table. And if you look at system columns filtering by country, you're gonna see that the low cardinality string is much more efficient in storage, which means faster queries in ClickHouse. Let's do a size breakdown of the different string data types. So we're gonna create a table with a column with a string, fixed string, and low cardinality. What we're gonna do in here is we're gonna insert 30 million country codes with this query. And if we take a look at the system columns for this table, we're gonna see low cardinality is the most performant one. Fixed string is not much better than string, but still has some savings in this case because take into account, even when we're using string, we're just ingesting rows with the same size, so we don't see savings in here. But so for order or preference, low cardinality for categories, otherwise fixed string, and you can fall back to string for any other text column. These are 3 simple tips to work with dates in ClickHouse, especially when you are designing your schema. As always, choose the right types for your use case, dates for rollups, datetime for events. Use the lowest precision you can. For instance, do you need 9 decimals in your datetimes? Probably not. And about time zones, the right pattern here is you store data in UTC and you convert at query time. Okay, so let's see some example about this. Let's create a table with 3 different date times, and we're gonna ingest 100 million rows, and now we're gonna evaluate the size of each column. So precision matters. Date time is 1 megabyte, 4 times more if you add 3 decimals, and 500 times more if you add 9. So choose the right precision. And about time zones, this is how it works in ClickHouse. You usually store your dates in UTC and you have functions to translate to any time zone at query time. Nullable columns in ClickHouse, 3 things you have to take into account. First thing is they need more storage because they use an extra bitmap. If null has no special semantics, then use defaults. Otherwise, fall back to nullable. That would be like my advice in this case. Let's see some examples about this. So I'm gonna create a table with a nullable column, and then I'm gonna create a separate one with a default value of 0. Remember, this depends on the semantics of your data, and we're gonna insert 100 million rows for each different table, and we can compare the size of each table, and we can see, of course, that the nullable table is a little bit bigger. ClickHouse comes with a set of special data types, and my advice here is very simple. Just stick to simpler types. Choose structured schemas because usually they mean faster queries. In this case, arrays are good, so whenever you need a list of items, you can use arrays for sure. Aggregate functions, you're gonna need them, and we will talk about them in a separate chapter. And about other types, JSON, enums, maps, tuples, UIDs, it basically depends on the use case. I might create a separate video about them, but my advice is clear. Just choose simple types in ClickHouse. Let's finish talking about the elephant in the room, which is schema evolution. Schema design in ClickHouse should be iterative and incremental, but the reality is the primitives you have in ClickHouse are not meant to simplify this kind of operation. So let's take a look at the primitives you have in ClickHouse to iterate schema. So for instance, this is a simple table with just one column. I'm going to ingest 100 million numbers. And if I want to add a column, I can alter the table, add the column, that's fine. I can modify the column just, for instance, to change the default value. That's perfect. But what if I want to rename a column? What happens behind the scenes? What's going to happen with downstream dependencies? We're going to need to find out, okay? More operations. Of course, you can also modify codec. And what's going to happen behind the scenes? There is no mutation. What ClickHouse is going to do, it's going to keep the current codec for the existing data, and the new data is going to use the new compression mechanism. Let's say we want to add, we want to modify the number column to an unsigned int. We can do it because it's part of the primary key. So we need to figure out how to change this column data type. Spoiler, it's not easy to do. So let's create another column, number with int 32. Yeah, we can change it to int 64 or int 16 because they are compatible types. But what's going to happen behind the scenes? It's going to do a full rewrite of the column. So again, it's going to be expensive, and probably you don't want to run this on the same ClickHouse cluster or ClickHouse servers where your production workloads are going on. So this is more or less like a sneak peek on the problems of schema evolution in ClickHouse. Remember, this is a series of videos we are recording called ClickHouse for Developers, in which we are unveiling the hard parts of ClickHouse and setting the base for you to learn about the basics and what are the right developer tools to work with ClickHouse.